So today we are finishing the unit on linear equations, and we're going to be talking about slopes of parallel and perpendicular lines. Okay, so make sure you add this to your notebook. We will come back to this, but I want to give you some vocabulary before we start. Okay, so on our vocab page, we have 3 vocabulary words we're going to add today. I know. The first word that we are going to add is parallel lines. Parallel lines are 2 lines in the same plane that never ever intersect. And then here's a sketch of 2 parallel lines. So parallel lines are 2 lines in the same plane that never intersect. And so then we also need to add perpendicular lines, which are 2 lines that intersect to form right angles. Okay, so let's also add this information to the page in our notebook. On the left side, I did 2 parallel lines, and on the right side, I did 2 perpendicular lines, and then we're going to explain in words what we know about the slope, and then we're going to do examples for each one, okay? What do we know about the slopes of parallel lines?
Never touch each other.
The slopes. What do we know about the slopes? We talked about this. They're the same. So parallel lines have the same slope. So if their slopes are the same, but we're looking at 2 different lines, will their intercepts be the same? Like the x and the y intercepts? No. So they have the same slope and different intercepts. Okay, so if I give you 2 equations and they have the same slope but different y-intercepts, they're still parallel lines, okay? So then we're going to do an example first of just parallel lines. So I want you to write down this example. Write the equation of the line that is parallel to y equals 2/3 x minus 1 and passes through the point 12, 5. So, really quickly, what do we know about the slopes of parallel lines? They're the same. So will you put a box around the slope in the line that's given to us? 12, 5. And then we also have the point 12, 5. Okay, guys, I have a slope and a point. Is that enough to write an equation? Yes. What form? Point slope form. Point slope form. So let's do it. Point slope form is y minus the y coordinate, which is what? 5, equals the slope, 2/3, times x minus the x coordinate, which is 12. If the problem did not specify which form to put it in, you can leave it like this. But because I gave you the equation in slope-intercept form, I want to put the new equation in slope-intercept form. So what would you guys do first? Yep. So that's going to be y minus 5 equals 2/3 x minus 12 is the same as 12 over 1. So 3 goes into 12 4 times, and 2 times 4 gives me 8. You also could have multiplied it out 24 over 3, but that reduces to 8. I'm not quite in slope-intercept form yet. The last thing I have to do, add 5 to both sides. So we get y equals 2/3 x minus 3. Done. And we know that this line and this line are parallel because they have the exact same slope, which is 2/3. You guys, everybody get it? Brianna, did you get it? Ernesto, did you get it? Or are you still writing? Okay. Okay, so let's talk about perpendicular lines. Okay, so perpendicular lines.
Wow.
We haven't really talked about the slopes of perpendicular lines yet, but let's see if we can come up with a hypothesis. Looking at this line going from left to right this way, is that one increasing or decreasing? Increasing. So will the slope be positive or negative? Positive. What about this one? It's decreasing, so the slope is going to be negative. So something about the slopes, they have to be opposites, right? Because this one is positive and this one is negative. Well, if they were the same slope but negative, the steepness would still be the same, because look at this one. This slope is not super steep, right? Is this one steeper?
Are they like opposites, like 3 over 1 and 1 over 3?
Yes, we call that opposite reciprocal. So they have slopes that are opposite reciprocal. And then we're going to add that term to our vocabulary. Okay? So perpendicular lines have slopes that are opposite reciprocal. And then we're going to add the term opposite reciprocal to our vocabulary. Okay, so the official definition of opposite reciprocals are two numbers whose product is -1. And then I will give you an example in just a second. Reciprocal. If I give you 2/3, if this is positive 2/3, the opposite is going to be negative. And what's the reciprocal? 3 over 2. So what do I mean when I say the product is -1? If I do 2 over 3 times -3 over 2, a positive times a negative gives me what? A negative. 2 times 3 is 6, and 3 times 2 is 6. So that reduces to -1. So opposite reciprocals, if you were to multiply them, you should get an answer of -1 always. What you need to be able to do is change the sign and flip the fraction. Okay? Okay, so this time I want to write an equation that is perpendicular. I have a point, and the slope of the line that I'm using is 1/3, so I can use that slope to find the slope that I need, right? And then I can use point slope form. So, what if my slope is 1/3, what is the opposite reciprocal of 1/3? -3 over 1, which is the same as just -3, right? Okay, so I would like you to write that down. Write slope equals -3, so that way you have it written down and you don't accidentally use 1/3. And then we're going to do the exact same thing by plugging it into point slope form. So y minus the y coordinate, which is what? 4, equals -3 times x minus 2. And then I do want you to put this in slope-intercept form. So distribute equals -3x plus 6, and then add 4 to both sides. So y equals -3x plus 10. So this line is perpendicular to the line that I gave you, 1/3 x minus 1. So the very last example, I want to know if the two lines that I give you are parallel, perpendicular, or neither. The first line is 4y equals -5x plus 12. And the second line is y equals 4 over 5x minus 8. Okay, so basically all we care about when we're talking about parallel and perpendicular lines is the slope. Which of the two equations, equation 1 or equation 2, is it very easy to just pull out the slope? 2. What's the slope in equation 2? 4 over 5. Okay, so if the equation is given to you in slope-intercept or point-slope form, it should be very easy to just pull out the slope from the equation. If it's not given to you in that form, you'll have to do a little bit of manipulating to get it in that form. And that's what we're going to do for example 1, or for equation 1. because I'm very close to slope-intercept form. What's the only thing that's preventing me from being in slope-intercept form? The 4y. So what can I do? Yes, and when I divide by 4, everything gets divided by 4. So this is divided by 4, and that is divided by 4. Okay? Watch. That gives me y equals, because that reduces, negative 5 over 4x plus what?
3.
Plus 3. And what's the slope of equation 1? Negative 5 over 4. Okay? So look at our two slopes. Are they exactly the same?
No.
Are they opposite reciprocal?
Yes.
Yes. So that means these two are perpendicular.
I said that.
Okay? So showing your work for something like this would mean writing out what the slope is, and if you had to manipulate one of the equations, show me the work that you did. If I manipulated the equation and I got that the slope of the first one was positive 4 over 5, they would be parallel, right?
Mm-hmm.
If I got that the slope was 3, they would be neither. That means that they're just two different lines that intersect at some point. Okay? So that is parallel perpendicular.